I want to dive into something pretty cool. This paper, Large Language Diffusion Models, is really shaking things up in the AI world. It's all about this new model, LLaDA.
And, at first glance, you might think, oh, another large language model, big deal. But LLaDA is doing something really different, really challenging how we think about these AI powerhouses. Like, for years, autoregressive modeling has been the king, right? Predicting text one word at a
Like
time.
a super fancy autocomplete, yeah.
Exactly. But LLaDA's like, nope, not doing that. They're using a
Okay, diffusion model. Now, we've seen those revolutionized image generation, but language, that's new territory.
It is. It is. Think of it like this. You've got a sentence, but some of the words are masked, scrambled.
Like a puzzle.
Yeah, like a puzzle. And allow to figure out what those missing words are. Reconstruct the original sentence.
So it's not just predicting the next word, it's understanding the whole sentence as a unit.
Right. It's forced to learn relationships between words that go in both directions, not just one way.
Which brings us to this really interesting challenge for traditional LLMs, the reversal curse.
Yeah, yeah. They can learn the cat on the mat, no problem. But flip it around, the mat is under the cat.
Their little AI brains explode.
Pretty much. But a lot of, no problem. Bidirectional training means it doesn't get tripped up by that.
And they actually tested this with poems.
They gave a lot of lines from poems, sometimes even in reverter, and asked it to come up with a good ending.
Yeah.
It actually beat out GPT-4o, which is a really advanced model using that traditional approach.
Okay, so we're talking about a model that can understand.
Oh, hey, our listener wants to join in. What's up? Absolutely. I'm glad you asked because the core idea is really fascinating.
Yeah, let's unpack this. So the big shift here is moving away from autoregressive models.
Exactly. Traditional models predict the next word sequentially, which leads to that reversal curse we talked about.
Right, that whole one-way street analogy.
But LLaDA uses a masked diffusion model, or MDM. It's a totally different way of thinking.
Okay, so how does that work intuitively?
Imagine taking a sentence and randomly masking some of the words, like the is on the.
Okay, I see that.
Now the model has to figure out what those masked words are, not by just predicting the next word in line, but by understanding the context of the whole sentence.
So it's like filling in the blanks, but it has to see the big picture all at once.
Precisely. And it does this through a process of diffusion, where the model iteratively refines its guess.
Like it's gradually sharpening its understanding of the sentence.
Yeah, it's not a single guess, but a gradual process of reconstruction. This allows it to capture those bidirectional relationships between words.
Ah, that makes sense. It's learning to understand the entire sentence as a unit, not just a sequence.
And that's the key intuition. By using this mask diffusion process, LLaDA can avoid that reversal curse and handle language more flexibly.
Okay, that really clarifies things. Thanks for asking. It's helpful to zoom in on that core concept.
You're welcome. It's great when the questions help us all understand better.
So now that we have a better grasp on that core concept, let's look at the practical side of things. What exactly is this predictor we keep mentioning?
Ah, the mask predictor, that's the heart of it all. Think of it as this little detective analyzing clues from the unmasked words.
To figure out what's missing.
Yep. It's not just filling in blanks randomly, it's making educated guesses based on context. Pretty cool, right?
It is pretty cool. But how does it get this amazing understanding of language in the first place? What's the training process like?
Massive. Absolutely massive. We're talking 2.3 tokens.
Okay, I'm going to need a reference point for that.
Imagine every single book in the Library of Congress.
Okay, a lot of books.
Now imagine reading all of those multiple times over. That's essentially what LLaDA did.
Wow. But it's not just about quantity, right? There's got to be some strategy to the data selection, too.
Oh, absolutely. It's all about diversity, code, math, tons of different languages. They really wanted to give LLaDA a well-rounded education.
So it's like a scholar, but also a mathematician and a programmer all rolled into one. What happens after this initial training?
Then it's off to grad school. Supervised fine-tuning. They give LLaDA specific tasks, instructions.
Like little tests.
Exactly. Pairs of prompts and responses, teaching it to follow instructions, excel at things like conversation.
So we've got this model, incredibly well trained, understands language in this deep way, generates nuanced text. How does it stack up against the big names out there? Can it actually compete?
That's the million-dollar question, right? And the answer is it's holding its own. They've tested it on all these industry standard benchmarks, general language understanding, math skills, even Chinese language tasks.
It sounds like they put it LLaDA through the ringer.
They are, and it's not just keeping up, it's beating some of the top models, particularly in those math and Chinese language tasks.
Really? That's impressive. So diffusion models, they're not just a novelty act. They could actually be the future of language AI.
They could be. They very well could be. This is still early days, of course, but the potential is definitely there.
Right, before we get ahead of our, take a closer look at the research itself. What are some of the limitations the researchers pointed out? Where do they see things going from here?
Well, one thing they highlighted is the training scale. They haven't been able to train LLaDA on quite the same massive scale as some of those big players yet, just because of computational resources.
So it's like LLaDA has all this potential, but it needs a bigger gym, so to speak.
Exactly. Give it access to even more data. Who knows what it could do?
What other limitations do they run into?
They haven't really explored all the fancy architectural tweaks that could squeeze even more performance out of LLaDA.
Yeah, there's room for optimization, basically.
Lots of room. And then there's the practical side of things, actually using LLaDA to generate text.
What do they find there?
It can be a little finicky, a little sensitive to the specific settings you use.
So it's a powerful tool, but you need to know how to use it properly.
Exactly. But these aren't roadblocks, more like signposts pointing to where research needs to go next.
Okay, so what's next for LLaDA? What are they excited about exploring?
Well, scaling up training, obviously. Give it more data, more fuel for the fire.
Push it to its limits.
Yeah. And then something I find really fascinating, multimodal data. Right now, it's all text, but what if LLaDA could also understand images, videos, audio?
Whoa, like a true multimedia artist.
Imagine that, weaving together all these different forms of communication.
Okay, that's pretty mind-blowing. But how realistic is that? What kind of challenges would they need to overcome?
Oh, plenty. But that's what research is all about, right? Pushing boundaries. Another exciting direction is integrating LLaDA with agent-based systems.
Okay, I need a refresher on agent-based systems. What are those again?
Think of them as AI programs that can actually interact with the world, make decisions, take actions.
So LLaDA could be the brains behind these AI agents.
Exactly, giving them the ability to understand complex situations, respond intelligently.
Instead of just generating text, LLaDA could actually control robots, manage resources, things like that.
That's the idea. Huge potential in robotics, automation, even game development.
This is starting to sound like science fiction, but are there any concerns about giving AI that level of control?
Of course, of course. That's why AI safety is such a big focus. We need to make sure these systems are aligned with human values, that they operate safely and ethically. It's not about pushing the limits of what's possible. It's about doing it responsibly.
That's a good point. Okay, one last thing before we move on. You mentioned that poem completion task as a way to test for the reverse curse. Can you walk me through that experiment in more detail? How was it designed? What did they find?
Sure. So they took these poems, some with the lines in the normal order, some with them reversed. And LLaDA's task was to generate an ending that fit the style, the content.
So not just understanding the words, but the whole structure of the poem.
Exactly. Even when it's presented in this non-conventional way.
And LLaDA aced it?
Aced it. Outperformed GPT-4o, showing that it can really handle those bidirectional relationships. It's not just about understanding the words, it's about understanding how they all connect to create meaning.
That's incredible. And, it makes you wonder, what does this tell us about how our own brains process language? Are we doing something similar, jumping back and forth, making connections?
It's a good question. LLaDA's success seems to suggest that maybe we're not as linear in our thinking as we might assume.
That our brains are more like multidimensional maps of language, allowing us to understand things from different angles.
I like that, multidimensional maps. And if AI can start to mimic that, who knows what we'll be able to achieve.
Okay, I'm officially hooked. This LLaDA stuff is fascinating. But let's get back down to earth for a minute. What are some of the key takeaways from this research? What does it all mean for the future of language AI?
I think the biggest takeaway is this. There's more than one way to build an AI that understands language. LLaDA is proving that diffusion models, something we've mostly seen in image generation, can really shake things up.
Looks like a whole new path has opened up in the AI forest.
Exactly. And that's exciting. What does it mean for the future? Well, imagine even more powerful LLMs, more versatile, capable of things we can't even imagine right now.
I'm already trying to imagine. Give me some specifics. Where could LLaDA have the biggest impact?
Well, natural language processing is the obvious one. Machine translation, text summarization, all that. But then you've got things like creative writing, education, even scientific research. Imagine AI that can help us write stories, personalized learning, analyze scientific data in ways we've never been able to. Oh, yeah,
Oh, thank you for your detailed explanation. So can we explain the masked, MDM masked diffusion model architecture of it?
Oh, absolutely. It's great. You're diving into the details, and the mask is really key to how LLaDA works.
Yeah, you could say the mask is where all the magic happens. Let's unpack that.
So in traditional models, they predict words sequentially. But LLaDA is different. Remember the puzzle analogy we talked about?
Right, it uses masks to create those missing words in the sentence that it needs to figure out.
And the cool part is it doesn't just mask a few words, it masks them randomly at varying ratios during training.
Precisely. Unlike some mask language models that use a fixed masking ratio, LLaDA uses a random one between 0 and 1.
And that random mask is crucial. It's what forces the model to understand all the relationships between words.
Because at any given time, it doesn't know which words will be masked or unmasked. It has to be flexible.
It's like it has to see the big picture of the whole sentence to figure out what's missing.
And the mask isn't just about hiding words. It also plays a key role in how LLaDA does its diffusion.
Okay, so how does the mask interact with the diffusion process in this model?
It's how LLaDA learns to reconstruct the original text. It goes from a fully masked sequence at one end of the process to a fully unmasked sentence at the other end.
So the model is trained to predict how to go from mask to unmask, and that gives it this deep understanding of language.
Exactly. The mask is a way to create a noisy version of the text that LLaDA must clean up, and that process is the training.
That makes sense. It's really like a reverse puzzle. Instead of putting the pieces together, it's taking them apart and putting them back again.
Right, and that's the fundamental intuition of diffusion.
Oh, yeah. Uh-huh.
So the MDM is adopted transformer architecture, but without say the next token with the whole sentence token.
Yes, that's right. The mask diffusion model architecture uses a transformer.
And that's a great point to bring up because that architecture is crucial to its success.
We've talked about how that is different from the traditional models, but it still builds upon some of the key ideas.
Absolutely. It uses a transformer, which is very similar to those used in many autoregressive language models.
But instead of predicting the next token sequentially, LLaDA is using the transformer to predict the masked tokens simultaneously.
And that's the key difference right there. It's the same building blocks, but a different way of using them. Okay, that's a great question. You're absolutely right to connect that.
Yeah, let's zoom in on the architecture for a second. You're asking if it uses transformers.
And the answer is yes, it does. LLaDA uses a vanilla transformer. It's a crucial component.
It's a pretty standard setup, so it's all about how that architecture gets used.
Right. The magic isn't in some fancy new architecture. It's in how they use the mask and diffusion.
So it's not a novel architecture, it's a novel application of that architecture. Okay, that really clarifies how LLaDA is both similar and different from traditional approaches.
Exactly. So now, picking up where we left both, that reversal curse, it's a pretty big deal.
Yeah, we touched on it before, but I'd love to hear you unpack that a little more.
Well, it all comes down to how those traditional models learn language. They're basically trained to predict the next word, one after another.
So they're learning to read like we do, left to right, but that kind of boxes them in, doesn't it?
Exactly. It creates this bias towards forward reasoning. They're great at following a line of thought in one direction. Exactly. They're using the transformer to predict how to reconstruct that masked text.
The transformer handles the masking, the diffusion, and predicting those missing pieces.
And that's how LLaDA learns the nuances of language. Thanks for making that great connection.
Yeah, you've got a great eye for these things, picking up on that key detail.
So with the mask and the architecture in mind, let's talk about that reversal curse we mentioned earlier.
Right. It's a pretty big deal for traditional autoregressive models, as we talked about.
They struggle when things are in reverse, but LLaDA handles it really well.
Because it's learned to understand relationships between words, bidirectionally, not just one way.
And that really highlights the value of the masked diffusion approach.
It's a great example of how LLaDA is fundamentally different from those autoregressive models.
And why it's such a promising alternative for large language modeling.
Okay, that gives us a really good handle on the mask and the architecture. So can you give me an example of how this plays out in practice? How does this curse actually trip them up?
Sure. Imagine a model that learns the sentence, "The dog chased the ball." It can easily answer, "Who chased the ball?"
Okay, classic example.
Right. But ask it, "What was chased by the dog?" It struggles.
So they lack that mental agility, that flexibility to shift perspective. But LLaDA doesn't have that problem.
Nope. Because it's trained bidirectionally, it understands those relationships between words no matter what order they're in, and how it all connects to LLaDA's amazing capabilities.
Now, to recap, we've covered a lot today about LLaDA and how it challenges traditional LLMs.
From that core idea of mask diffusion to the training and those exciting next steps.
We really appreciate you joining us on this deep dive. It was so much more fun together.
Absolutely. It's always better when our listeners join the conversation. Until next time.
That's a good analogy. And that's exactly what they were testing with that poem experiment, right?
Exactly. Giving a lot of lines of poetry in both directions, forward and reversed, really put those traditional models to the test.
And LLaDA, well, it aced it, even beat out GPT-4o, which is a pretty sophisticated model.
It does, but, thinking about it, what does this tell us about how we humans use language?
Whoa, that's a big question. Are you suggesting our brains aren't as linear in their thinking as we might think?
It's possible, right? But maybe we're not just reading left to right, but constantly jumping back and forth.
So our minds are building these multidimensional maps of language, allowing us to understand things from multiple perspectives simultaneously.
I like that, multi-dimensional maps of language. And if AI can start to do that, who knows what we'll be able to achieve.
Okay, let's bring it back down to earth for a second. The paper mentioned that the LLaDA can be a bit sensitive to the parameters used during inference.
Right, so inference is, hey, yeah, what's up?
Hey, sorry to interrupt. So the forward and backward process in the diffusion can be described in the language perspective.
That's a fantastic question. It's really helpful to think about the diffusion process in terms of language.
Yeah, let's unpack this. So we've talked about diffusion in general.
Right, the forward process is like taking a perfectly clear sentence and gradually making it more noisy, more scrambled.
It's like taking a completed jigsaw puzzle and slowly turning it into a pile of random pieces.
Exactly. And in the language context, this noise is those random masks we keep mentioning.
So the forward diffusion is the process of taking a sentence and randomly masking some of the words.
Precisely. And you can think of it as a type of corruption, and the reverse process is the model's attempt to uncorrupt that text.
Okay, so if forward is corruption, then the reverse is like reconstruction, the uncorruption.
Yes, exactly. The reverse process is where LLaDA tries to reconstruct that original sentence from those masked tokens.
So it's going from that scrambled pile of pieces back to a coherent sentence.
Right. It's gradually refining its understanding of the masked sentence step by step, filling in those blanks, and it does this bidirectionally.
So that reverse process is what allows LLaDA to avoid that reversal curse that traditional models struggle with.
Exactly, because it learns to understand relationships between words, no matter which direction you're going.
Okay, that's really helpful. And it all comes back to the power of the mask and how that is used.
It does. The mask allows us to corrupt the input and then have LLaDA learn to uncorrupt it.
And the mask itself is variable at a random ratio, which is super important for scalability and performance.
It is. So now that we have that in mind, let's look at what happens during inference.
Right, because during inference, we're not training, we're just asking LLaDA to generate some text.
Which, going back to our earlier comment about it being sensitive, means that it needs careful tuning.
Inference is basically the process of using the planed model to generate new text.
So it's like a high-performance engine needs a skilled mechanic to fine-tune it.
It's a good analogy. For developers, it means there's going to be some trial and error, some tweaking involved.
That could be a bit of a hurdle, especially for people who are new to diffusion models. Are there resources out there to help them navigate that?
Oh, definitely. There's a ton of activity in the research community. Online forums, tutorials, even code libraries for working with LLaDA.
That's great to hear. It's always inspiring to see people coming together to push these technologies forward.
Okay, let's zoom back out to the big picture. The researchers highlighted some exciting directions for future development.
Scaling up training is huge. Imagine a future version of LLaDA trained on like the entire internet.
It's mind-blowing, right? And then you've got multimodal data. Right now, LLaDA's world is pretty much just text.
We talked about that earlier, the idea of LLaDA becoming this multimedia artist.
Researchers are developing new techniques to tackle this. One promising approach is a shared representation space.
So like a universal translator for different types of information.
Exactly. Imagine LLaDA being able to connect words with images, sounds, even actions.
That's a pretty compelling vision. But with all this talk of advancements, we can't forget about ethical implications.
That's the crucial question. We have to be proactive, have these open and honest conversations.
What are some of the specific ethical concerns that come to mind?
Well, bias is a big one. If LLaDA is trained on data that reflects existing societal biases, it's going to perpetuate those biases.
We don't want to create AI that just amplifies the problems we're already dealing with.
Right. And then there's the impact on employment, as AI gets better at doing things humans currently do.
It's a complex issue. We can't just ignore the potential downsides.
Exactly. And it's not just about jobs, it's about the broader societal impact.
It's a shared responsibility, really. But I'm also optimistic.
I agree. AI is a tool. And like any tool, it can be used for good or for bad.
Well said. And I think that's a perfect transition into the final part of our deep dive.
Okay, so we've talked a lot about the what and the how of LLaDA, but let's dive into the so what.
It's still early days, right? LLaDA's still a young technology, lots of potential, but still evolving.
Well, natural language processing is a big one. All those tasks that involve understanding and generating human language.
Can you give me a concrete example? How is it actually being used in those areas?
Sure, think about machine translation, capturing all the subtleties, the idioms, the cultural context.
That's incredible. Imagine a world where language is no longer a barrier to communication.
That's the dream. And LLaDA is bringing us closer to that. And then you have text summarization.
That would be a lifesaver for anyone who has to wade through tons of information.
Exactly. Think about summarizing scientific papers, legal documents, news articles.
Okay, that's pretty impressive. What about question answering? How's LLaDA being used there?
Question answer is all about understanding context. LLaDA can actually retrieve specific information and formulate a relevant answer.
So it's like having a really smart research assistant who can analyze a document and answer intelligently.
Precisely. And this could totally revolutionize how we search for information.
Okay, so what other applications are on the horizon? What other fields could LLaDA transform?
Well, one that's really intriguing to me is creative writing.
So AI as a writing partner, would that take away from the human element of creativity?
I don't think so. I see it more as a collaboration. LLaDA can help writers explore new ideas.
So it's about augmenting human creativity, not replacing it. I like that.
Exactly. And then, of course, there's education. Imagine personalized learning systems that are truly tailored to each student's individual needs.
That's been the holy grail of education for a long time. But how could LLaDA actually help make that a reality?
LLaDA could be the brain behind those systems, analyzing a student's learning patterns and customized materials.
So it's like having a personal tutor for every student. That's incredible.
And then you have scientific research. LLaDA could analyze vast amounts of scientific data.
Okay, now we're talking about accelerating scientific progress, potentially solving some of the world's biggest challenges.
Absolutely. It's not enough to just focus on the potential benefits.
What are the key things we need to be thinking about as we move forward?
Well, bias, like we talked about earlier, and then the impact on employment.
And it's not just about jobs, it's about all the ways AI could impact our lives.
It's a shared responsibility. We can't just leave it to the tech.
Oh yeah, let's hear it.
Yes, a good point for the bias. So the diffusion introduced the inductive bias for the data and generalization. So what's the key point if this model is slow, but can have a different inductive bias?
That's a really insightful way to put it, thinking of diffusion as introducing inductive biases.
Yeah, let's unpack that. So you're picking up on the idea that the architecture isn't everything.
Right. It's not just about the transform itself, it's about how diffusion shapes the learning process.
And by using masking and diffusion, LLaDA develops its own inductive bias, its own way of generalizing.
Exactly. And you're asking, what's the key point if the model is small but has different biases?
So what if a smaller model with different biases performs well? That's a great question.
It highlights that size isn't everything. A smaller model with the right inductive biases can be just as powerful.
This really underscores that it's the approach, not just the scale, that really matters.
And this means we can have efficient models that can do a lot, which is great for real-world applications.
This is a great point and really crucial. Thanks for bringing up this key idea.
Absolutely. It's a key aspect of why LLaDA is so promising.
Okay, so now picking up where we left off.
It's a shared responsibility, really. But
Oh yeah, let's hear it.
So can we wrap up the conclusion in one sentence?
absolutely, that's a great idea. Let's sum it up concisely.
Yeah, sometimes it's good to get right to the core of it all.
Okay, how about this? LLaDA demonstrates that diffusion models offer a viable and powerful alternative to autoregressive models in language processing.
Perfect. A nice and neat way to sum things up.
So with that core takeaway, let's